velocity in this one? 150 feet per second. Okay, what's theta? 18 degrees. That's all we need to write our equations. Oh, you're right. We need the initial height, which is 3. Alright, so the horizontal motion of the ball, the way it's going to move horizontally, is going to be described by x equals 150 times cosine of 18 degrees times t. And then y is going to be negative 16 t squared plus 150 sine of 18 degrees times t plus 3. Okay. So now I'm going to show you how to put the fence on. Well, we'll put this on first, and then I'll show you how to put the fence on. 150 cosine of 18. In a second, we're going to switch to degree mode, just in case yesterday you graphed things and they were in reading mode, because we're in degrees now. So, are we good? You understand how I got that? Go to mode. Make sure we're in degree. Let's go to window. Now, you're going to want to think about, again, t is time. How long do you think that the baseball, if you hit a baseball or softball, would be in the air for? You think 10 seconds? Sure, we can do 10 seconds if you want.
It depends on how far. I don't know.
That's got to be a world record. Probably not 10 seconds, but not a lot. Definitely not, 20 or 100. Sometimes people will just put random things in there and they'll be like, my graph just keeps going forever. I'm like, well, because you're graphing it for 300 seconds. That's going to take a long time to graph. So pick something that's reasonable. We could do 5. I think 5 would definitely be an overestimate. Okay. So Kevin hit the ball 18 degrees, and we want to check if it's 400 feet away. So don't I have to at least, if I want to check if it makes it 400 feet away and clears the fence, don't I have to at least go to 400 then for x max? Okay, so I'm going to make my x max 450. Again, think of a baseball hit up in the air. I mean, it's 18 degrees, it's not a super steep angle. How high do you think it would go? Like how high in the air? You're not answering, Candace. I scarred you. I'm going to do that. I mean, think of even a pop-up, right? A pop-up fly, it's not going to be that high. I don't know. You can still see it, right? All right, I'll try 50 feet. Hit graph a second. All right, so there's the baseball. If you wanted to figure out what its position was at different times, you could hit trace. So let me show you how you could figure out if it will clear the fence. We need to go 20 feet away. 20 feet away, so that's x. So let's let's see, get to 20. Oh no, hold on. Oh, a 20-foot wall. Sorry, we have to get to 400 feet away. Whew. So now I'm 399 feet away. Uh-oh. The ball is now 399 feet away, and how high is it? 7. So is it going to clear the fence? No. Okay. So here's what I would write for my reason. No. At 400 feet, the ball is, what, about 7 feet high? Okay, here's how you put the fence on. You can actually put the fence on the picture. To put the fence on, what we do is we make, we go into our parametric equations and we put where we want the fence to be. How far away do we want the fence to be? How far away? 400, and we put that x because that's how far this way. And then we put the height of the fence, and then we do t divided by whatever the t max is in your calculator, because we want it to stop at 20 when we get to the end of the problem. So what was t max here? What did we make our t max? Was it 5? Okay, so let's go back in our parametric equations and put this in, and then you can see actually it hitting the wall. Okay. Okay, so then you can clearly see, do you see that the ball would hit the wall right there, so obviously wouldn't clear it, okay? Let's just play around with this a little bit. What would Kevin maybe have to do to adjust his swing to clear the wall? Like, could we change in the problem that might clear that wall? Give me something. If he hit it at a higher initial velocity, or if the angle was higher. Okay, so let's say, you don't have to do this, I'm just going to play around with it. Let's say he hit it at a 30-degree angle instead, with the same initial velocity. Let's see if it would clear it now. Uh-oh. 100%. Looks like it did. So let's say, let's go back to 18. Oh, really? Okay. Let's go back and let's say we changed his initial velocity to 200 feet per second. And let's see if that would make a difference. Okay? So different angles and different velocities are gonna produce a different answer to that question. Your wall doesn't show up? That doesn't show up? Even the first time? Okay. Are you in degree mode? Okay, I'll look at it.